Hello everyone. So today we are going to start another playlist which will be focusing morely on 2D grid related questions in the DP, some 3D questions which I wanted to focus on, and then maybe some string related DP questions also. So all these three combined in a middle mm, difficulty level DP questions, but still DP on grid is very easy um, once you get the template, like it's way simple than to think. Okay, so grid, of course you know that there is a 2D grid and this will be a 2D DP only, so no need to think of that. Okay, so anyways, that part will be solved, and then we're going to see, like today we are going to see simpler questions on the DP on grid. And how are we going to solve? Like we exactly see the proper method to write the code, what all functions you need to define there, and how your functions should be called, and how the code should look like. It shouldn't be messy. The code is simpler for the DP on grid, but then how you write that code matters a lot while working with the grid type questions. Okay, so without wasting time, let's just deep dive into that. Okay, so we will be focusing on, okay, DP on grid, which is again a 2D DP type of questions. Okay, you will be given a 2D DP of, let's say, n cross m, a grid given of n cross m, and there are three type of questions like minimum path sum, a max path sum, and total possible paths. Now, these are the only three main variations which could be asked for any type of grid. Now, what you will be given? Given could be a starting point, ending point, not necessary, okay? Could be given or not given, not necessary, okay? Some other things should also be given, like some restricted areas or restricted cells, okay? Or the directions to visit, okay? Which will be given to you. Directions to visit, which could be four directions, two directions, or six directions, basically, eight directions. Sorry. These are the only things which could be asked, okay, which could be possible directions. Okay, I don't think anything else. These are the only basically things which will be given to you for the DP on grid type of questions. Now, what functions you need to build before executing this? So there should be one function called bull safe cells. Okay, what this does? Check uh, check indexing of arrays. It should not go out of the bound. It should not go out of bound. Okay, and the other thing is restricted shells should not be visited. Restricted or whitelisted or all those kind of things will be given to you, should not be visited. So if any of these two things will be there, you will return false. So what you will pass here, your current index, which will be int I j, and your n m, and your grid, okay, to check whether this particular is restricted cell or not. Okay, so this is the bull safe which you need. Okay, now another thing is the base condition. Now, your base condition could be depending on the end cells or the destination cells. So, once you reach your destination cells, uh, you can return 1, 0, or anything like total sum or anything. Okay. And if you go out of bound, so if not safe, you may return 0, or if int max or int mean, depending on the question. But we will not follow this path. We will not follow this path. We will have only one base condition, and what we will do is, while moving forward to any other cell, to any other choice of cell. Okay, you have choices like here, directions are like choice. Why did we use DP? Again, the question that arise could be why DP? Then we have choices. From particular cell ij, I could go up, I could go right, I could go left, I could go down. So there are four different choices which I could move. And that's why we are using DP over here. Okay, so while moving forward to any other choice of cells, check whether it's safe or not to move there, whether it's safe or not safe to move. Okay, if it's a safe, then only move, otherwise do not move. Okay, another important thing is make an array of possible directions. Make an array of possible directions. So for example, for four-way directions like up, left, right and down, for this kind of things, your array should be like 0 1, 0 minus 1, minus 1 0, 1 0. Okay, so this is like incrementing 1 in jth position, decrementing 1 in jth position, decrementing 1 in ith position, and incrementing 1 in ith position. So this will be I plus 1j, which is nothing but up. This will be I minus 1j, which is nothing but down. This is ij minus 1, which is nothing but left. And this is ij plus 1, which is nothing but right. Okay, so every time, so we'll have then a for loop for each choice of direction. I hope you got the point. Okay. Okay. If it's two way, there could be only two entities. If there are six possible ways, six entities. Eight possible ways, eight different entities. You need to think and put it in plus or minus one, two in that format. Okay. What you have to do is I plus one or I plus two or whatever. Okay. If there could be some questions where your knight is moving in chessboard. Okay. Your knight could move in any L direction. Okay. It could be any L direction, so it could be minus 1 and then two positions over here, let's say plus 2, or it could be plus 2 and minus 1. Okay, sorry, plus 1, or it could be minus 2 and plus 1, or it could be this way means plus 1 and minus 2. Okay, all eight different combinations you could make over here. Okay, minus with 1 and 2, like minus 1 plus 2, minus 1 minus 2. Similarly, plus 1 plus 2 plus 1 minus 2. Then minus 2 plus 1 minus 2 minus 1 and plus 2 plus 1 plus 2 minus 1. So these are the eight different possibles you can choose for a knight to move in eight different directions. Okay, it could be queen, it could be knight, it could be anything, it could be bishop. So that way you need to define the directions possible for a particular element to move. Okay, particular robot or anything given to you. Now, your basic template would be like integer solve. Okay, you'll be basically passing 0 0 or your start positions, start I, start j, which will be most probably 99% given to you, the start positions. Okay, and then you have your grid and your n and m. Okay, now first your base condition. Okay, now if it's related to number of paths, then if you are already at that particular cell, that could be one possible path only, so that you need to define. Now you know how to define base condition. We already had a full playlist before linear DP wherein I explained in each and every video how to define the base condition. Cool. Okay, we'll check the DP condition. DP basically is 2D DP. So if DP ij is not equal to minus 1, we'll return that DP ij. Okay. Now, now, now the main case arises. Okay. Now it could be total sum, it could be total path. Okay, it could be anything. Max sum, max path. Define whatever given to you here in your question. Now make a loop for int k is equal to 0 till k less than whatever is your directions you define globally. So go until that length. and k plus plus. Okay. Now you have two different coordinates, which are your new coordinates. It will be new I, which is I plus your directions of k 0 or k dot first. If you have to find vector of pair, if you have to find vector of vector, it could be k 0. But basically, it's better to define vector of pair because we only have two elements, I and j. So direction of k dot first. Okay, and your new j will be your j plus directions of k dot second. So these are your new coordinates. Now if safe cells, what these two are, new I and new j are safe, then only we have to move there. We'll pass nm and grid, put the conditions and save. If that is true, then only you will do dp of ij is equal to something something plus solve of new I new j and the same. So then this is the recursion and you will return this dp of ij. Okay, or you will do maximum and then do. Now that depends on your question, but this is the basic template which you should remember. Okay, let's solve one question and then you'll get it. Okay, so now we have this unique paths 2 question which says that you are given m cross an integer array grid. Now there is robot initially located at top left corner. So you are given the starting cell which is 0 0. Robot tries to move to the bottom right corner which is m minus 1 n minus 1. Now, robot can only move either down or right at any point in the time. So it could move either I means row same and j should be j plus 1, or it will move down. So I should be I plus 1 and j should remain as it is. So you know that your directions array could be plus 1 0 and 0 plus 1. Okay. Now, an obstacle and space are marked as 1 or 0 respectively in the grid. So, if it is obstacle, it is 1. If it is space, it is 0. So, if the current cell is 1, then you cannot visit there. Okay. So, it cannot include any square that is an obstacle. Now, we need to return the number of possible unique paths that the robot can take to reach the bottom right corner. Now, will be less than or equal to 2 into 10 raised to 9. Okay. Okay, so initially we'll have what is our I and j? Length is 100. So we'll make a dp of 105, 105. Okay, we'll have a solve where we'll have int I, int j, and we have this vector of int m percent grid and our n and m for sure. Okay, okay, cool. I'll have one vector of pair of int comma int, which is directions, which is sorry 1 0 for for down and 0 1 for right. Okay, now what could be a base condition? If you have reached that cell, that means your count will be increased by plus 1. Okay, so if your grid of I, sorry, if your I is equal to m minus 1, m is your rows, and j is equal to n minus 1, that means you have returned the last cell. So number of possible paths from that cell to that cell is again 1. So we'll return 1. This is our base condition. Okay. If dp of I j is not equal to minus 1, we'll return dp of ij. Now, I have two possible directions. For int, k is equal to 0 to k less than 2k plus plus. My new I is this older I plus directions of k dot first, and my newer j is this j plus my directions of k dot second. Now we'll make a variable is safe for this new I and new j passing n and m and grid. If it's safe, we'll move. So my dp of ij plus equal to, so I'm moving. So that will be plus equal to solve of new I, new I, new j, grid and m. Okay. Because I'm moving, I'm doing the number of paths from starting from this new I new j now, and I'll add that. Okay, we will return dp of ij. When this solve function returns 1, only when you reach the end cell. So the full path has been traversed and you reach the end cell, that path will return plus 1, which will be added to the dp. Okay, let's make a bull isSafe function. Int I, int j, int n, int m, and vector of int m% grid. So if your I is less than 0, or I is greater than equal to m, or your j is less than 0, or your j is greater than equal to n, or your grid of ij is equal to 1, that means obstacle will return false, else we will return true. Okay, I'll memset this thing. Okay, now your int m is obstacle grid dot size, and your n is obstacle grid 0 dot size. Now the 0 0 and 1 1 could also be 1. I mean that could also be an obstacle. They haven't said that. So they said that the ij is 0 or 1. Okay, they haven't said that starting and ending position won't have 1. So we need to check if obstacle grid of 0 0 is 1, or obstacle grid of m minus 1 n minus 1 is 1, then from here only we will return 0. I mean that means that there are no possible paths. Okay, so we'll return 0. Cool. And we'll return solve of 0 0 obstacle grid. So initially I have to pass n and m, and obstacle grid. Cool. We need to have one sum variable. We directly cannot update dp of ij. Dp of ij will be the summation from all the paths put into that particular path. So we'll have one variable called sum, which is 0, and we are adding this solve functions, whatever answers are coming to sum, and then we are putting that dp of ij as the sum, as the number of unique paths. Cool. Okay. Tried submitting it. Okay, now there is another question which is similar to this, which you can solve by yourself, which is given m cross n grid with some non-negative numbers, and you need to find path from top left to bottom right, which minimizes the sum of all numbers. So you can move down or right, okay, and you need to do the minimization of sum. When you move from here to here, you need to do the minimization of sum. So the sum should be minimized. So you need to take the number, okay, and every time you have to take that path which path has the minimum sum. Now if you are already at here, your base condition is if you are at the end position you will return 1. For this, if you are at end position you will return 6. Whatever is the number, you will return that. But for other things, like we did sum, now you have to do the minimum of all paths. So while running the for loop, you have to do minimum from right direction and down direction. Here also two directions only you can move. So whether moving right reduces your path or moving down. So you have to do minimum of both and then put that minimum answer to your DP. Hope you can solve it. We'll solve another kind of triangular grid kind of questions in the next video. So stay tuned, stay safe, do like, share, and subscribe.